Hello everyone. Today I'm going to show you about phasors in electrical engineering and how to deduce them, how to use them, and adding and multiplication of phasors. So let's get started. So we know all know when in our electrical engineering we get phasors in different forms like mm, polar and rectangular form. So suppose one equation has given like this one. So V is equal to V of cos omega t plus theta. So in this case, this is the amplitude of voltage. So this is the phase angle. So in polar form, we can take it like this way. So V of angle theta. So this one, this V amplitude and the theta. And when we take the rectangular form, so we can write this as a plus jv. This a and b, this we get it from this, from here. uh, if we draw a real versus imaginary Cartesian plan, this is real and this is imaginary axis. So suppose this is the v, where this is b and this is a. So it's like, so a is nothing but v of cos theta. So this is theta, and b is v of sine theta. And everyone j is nothing but root over minus 1. In mathematics we call it I, imaginary number I, but in electrical engineering I has a different meaning. For ampere, for I is current basically. That's why to avoid the confusion we use J in this case. So this is the rectangular form and this is polar form. So suppose one, and from rectangular form to polar form we can get it by v is equal to root over a square plus b square. Sorry, my square sign is a bit, and theta we can get it by tan inverse b by a. So now we are going to see one example of phasor uh, in polar form and rectangular form. So we are going to take one signals voltage of 10 cos 100 t minus 60 degree. So this is our given signal, and we are going to convert this signal to polar form. So you will take this v as it is and take this minus 60 degree. So this is our polar form of this signal. So if we want to convert this to rectangular form, we have to do some uh, calculations. So we know that rectangular form is in this form jb. So this j is nothing but root over minus 1. So to calculate this, we have to take this a A is V cos theta and B is V sin theta. So if we want to draw this signal, so this is minus 60 degree and real axis, imaginary axis. So we are going to calculate this V cos theta. Here V is 10, cos theta means cos 60 degree. So we know one thing, that we can write it here, cos minus theta is equal to cos theta, and sine minus theta is equal to minus sine theta. So here we are going to get 10 of cos 60 degrees equal to half, so we are getting 5, and here V sine theta is 10 sine minus 60 degree. We will get because sine 60 degrees is root 3 by 2, so sine minus 60 degree is equal to minus root 3 by 2, so 10 minus root 3 by 2 is equal to minus 5 root 3. So if we were going to put this value here, we are getting 5 minus j 5 root 3, 5 root 3. So here this is our final rectangular form, 5 minus 5 root 3 of this value. So now we are going to see how to add and multiply two signals or phasors, whatever you call it. So I'm going to take two voltage, 5 cos omega t plus 60 degree, and another voltage would be something around 10 cos. So I'm taking this for easy calculation, omega t plus 30 degree. So I'm not taking any negative angle to avoid any complication. So here, so this is the given value phasors, and I'm going to convert this to polar form. So this will come 5 and 60, 5 and 60 degree, and this will for P2 will get 10, 30 degree. So we have to convert this to rectangular form. So I am taking converting this. You know, 5 cos 60 degree would be half. So half means 2.5 plus j of 5 sine 60 degree, it would be root 3 by 2. So 5 root 3 divided by 2 means 5 into 1.73, so it will come down to 4.33. And for this value, we'll take Similarly, so 30 degrees means 10 cos 30 degree. Cos 30 degree means root 3 by 2. Root 3 means 1.73, means 10 into 1.73 means 17. 17.3 divided by 2 means 8.65. So 8.65 plus j of 10 sine 30 degree means half 5. So I'm going to add these values here. It will come to 11.15 plus j of 9.33. So one thing we should remember that for addition and subtraction, we have to convert this polar form to rectangular form, because in this form it is easier to do this calculation, and then we will if necessary we will convert this to final polar form. 2 is equal to, so here we have to do a little calculation, like something like 11.15 square plus 9.33 square and 10 inverse 9.33 divided by 11.15. So it will come to 14.54, 39.92 degree. So this calculation you can take it and you can do it by yourself, like just Pythagorean equation, and this is sine portion, this is cos portion, so sine by cos is equal, you will get the theta from here. So if we want to get the final Vt, it will be 14.54 cos omega t plus 39.92. So this is the final Phasor. So now we will see how multiplication and division operation can be done. So suppose if some v and I value has been given here, so if we want to multiply those two terms, we have to multiply like this one, v theta 1 multiplication with I theta 2, then it will be vi theta 1 plus theta 2. And if we want to do the division operation, v by I, it will be v theta 1 divided by I theta 2, it will be v by I theta 1 minus theta 2. So if we want to see one example, suppose v is 10, 30 and I is 560 degree, then vi would be 10, 30 degree into 5 in 60 degree, so we'll get 50, and 30 plus 60 degree, 90 degree. And if we want to divide them, like if we know R is equal to V by I from Ohm's law, so this 10 by 5 and 30 minus 60, it will be 2 minus 30 degree. So it's very easy for multiply and division operation, because we don't need to convert this polar form to rectangle form, so it takes lesser time than addition and subtraction operation. So okay.